Zimbopreneur, a platform where we are bringing the digital experience to your learning process. And we continue with our online animated Maths Ordinary Level course. And today we are into vectors. A very big topic, and when it's in the exams, it has a lot of marks. So this is more of an introductory video, which is compiled within the 5 minutes. Probably the next video will be around 30 minutes, so that everything under vectors has been done. Now, a vector, when you hear the word vector, just know that vector, it has to do with direction and size. A position of something being measured using the direction and size. Basically, that's what vectors are all about. Now, vectors can be represented on the Cartesian plane. We have our x-axis there and a y-axis. Y-axis, I'm writing as I'm going down 3, 2, 1. And we have point A, can be represented as vectors, position vectors. Now, the position vectors of A and B can be represented by A. And we have column vectors. And column vectors, that's where we say AB is equal to A, just as it is written on the diagram. Or we can write the direction and represent it, the movement in the x-axis and the movement in the y-axis. And for you to get from A to B, you move from 1 to 5 in the x direction, that's in the positive direction, 4. And then you move upwards. Again, that's in the positive direction in the y-axis. 1 upwards, even though I'm drawing downwards. 1 in the y-axis. So that's how we get AB as 4 and 1. So if it's BA, you're now moving in the opposite direction. So you just assign a negative sign or multiply by a negative sign, which is now a scalar multiplication when we use the terminology from matrices. So BA will be minus 4 minus 1. So if you name a vector when it's using a certain direction, when it's the opposite direction, then you just multiply with a negative sign. This is a trick that you need to remember every time you're calculating vectors. Then we move on to the magnitude. This is not a new word. If you're that smart, you know what magnitude means, and you might get a glimpse of what we mean when we are saying magnitude. So AB is 4 and 1. We have represented it in a Cartesian plane. We are representing it as a matrix, 2 by 1 matrix. And how do we find the magnitude of AB? We use the Pythagoras theorem. We're going to square the x and the y, the square root of x squared and y squared. So that's 4 squared plus 1 squared. That's the square root of 17. So the magnitude of AB is square root of 17. Now let's do a practice question so that we can see whether the concept that we are talking about, we've completely grasped them. Can we calculate the magnitude of a matrix? So a typical exam question on the screen, not really clear, so I'll be talking it aloud. We have a scenario whereby A is 3 and 1 minus 1 and 4. Let's start with A. we have a negative multiplying that matrix 3, 1, or the position vector.